Hi, my name is Philipp Sacher and I am a Specialist Solutions Architect for IoT here at AWS. In this session, I will talk about managing industrial data at the edge with AWS IoT SiteWise. What I'm going to cover is use cases for edge processing, our new feature AWS IoT SiteWise Edge, and also options for custom data processing. And finally, I will show you a demo how to set up SiteWise Edge. What are common use cases for processing data at the edge? For example, you might want to reduce the latency for your local applications and also ensure business continuity, even if the internet connection is not available. Or you want to consume your data already at the factory level. So if you want to have a dashboard at the factory level, you don't need to send the data up to the cloud and then look at the same dashboard that consumes the data from the cloud. So you want to have, for example, your dashboards available at the factory level in your facilities. Or you might also want to consume data from other data sources than the data sources that are provided out of the box from our services. So first of all, let's take a look at AWS IoT SiteWise in general. AWS IoT SiteWise is a fully managed service and it has several components. It has a gateway to collect data from industrial protocols like OPC UA, Modbus TCP, or Ethernet IP. Then you can create models to model your physical assets, your processes, or your facilities. And with SiteWise Monitor, you can create fully managed web applications to visualize and analyze your equipment. At reInvent 2020, we just launched AWS IoT SiteWise Edge in preview. This is a new capability of AWS IoT SiteWise. AWS IoT SiteWise Edge brings features of AWS IoT SiteWise to the edge. So AWS IoT SiteWise Edge will be installed on a gateway, which could be, for example, an industrial PC in your environment. You can now process data at the gateway locally and visualize equipment data locally with a SiteWise monitor that is also installed locally on your gateway. For example, you can compute metrics like the overall equipment effectiveness locally to use it in your production line and create monitoring dashboards on the factory floor. So with AWS IoT SiteWise Edge, you don't need to do all the heavy lifting that you need to do if you want to install your own solution at the edge, like maintaining and installing components like databases, like software to create dashboards and so on. So let's take a look at the services and components which are required here for edge processing. First of all, you have your data sources like industrial protocols. Then you need to have Greengrass running on a Linux box, for example. It can also run on the Snow family from AWS, or it can run on AWS Outposts. You need to have Greengrass version 1. And of course, AWS IoT Core is also involved in the setup because Greengrass is connected to AWS IoT Core to send data to the core or also to get deployment information for your Greengrass setup. Then you need to have AWS IoT Greengrass Stream Manager enabled for your Greengrass setup because that Stream Manager will be used by several gateway components. Then you might also bring your own Lambda functions to interact with these streams. What you also need to have is the AWS IoT SiteWise connector. And for SiteWise Edge, you need to have the AWS IoT SiteWise Data Processor connector. That is a component for processing data at the edge and for creating dashboards at the edge. So If you want to set up edge capabilities, as I mentioned already, you need to have a box where you run AWS IoT Greengrass. Then you need to install also Java 8 on this box, Python 3.7, and you need to have Docker and Docker Compose on this box. Then you need to add the IoT SiteWise data processor connector to your Greengrass group. This will deploy it also to your device running AWS IoT Greengrass. Then you need to configure the gateway of AWS IoT SiteWise to process your data at the edge. And finally, you need also to configure your asset model for edge processing. In the asset model, you define which properties will be computed and processed at the edge, and the results will then be sent up to the cloud for long-term storage. So we have also a term that's called destinations. So destinations are simply streams on AWS IoT Greengrass. And a destination lets you control where your incoming data from your data sources will be sent to. By default, you have a stream that is called SiteWise Edge stream. In this example here, you can see two data sources, two OPC UA servers. One OPC UA server sends the data to the SiteWise stream. So that means not the OPC UA server directly, but the component from SiteWise that gets the data from your server and sends them to the stream. So in the case you want to do edge processing with AWS IoT SiteWise Edge, you send your data to the SiteWise Edge stream. And now let's take a closer look at the architecture with streams and Lambda functions. So the default option is you install the AWS IoT SiteWise connector. It brings two Lambda functions, a reader or a collector Lambda function that gets data from your industrial protocols. We supported OPC UA for a long time. At reInvent, we have launched also support for Modbus TCP and Ethernet IP protocols. And the collector writes the data to the SiteWise stream. Then you have another Lambda function that is also part of the SiteWise connector. That is a so-called publisher or writer Lambda function. And this Lambda function reads data from the SiteWise stream and transfers the data to the AWS IoT SiteWise data store in the cloud. Another option is that you bring your own custom Lambda function to write into the stream or to read out of the stream. And with a custom Lambda function, you can support data sources that are not supported by AWS out of the box. Might be you have an OPC DA server, or you want to get data out of a database and send them also to the AWS IoT SiteWise data store. So next, let's take a look at the new custom option. So we also launched a feature at reInvent so that you can send data to your custom stream. You will still use the collector Lambda function from the SiteWise connector, but then you define a custom stream. You can also use your own custom Lambda function and write to the custom stream. So what can you do with a custom stream? For your own stream, you can create a so-called export configuration. And an export configuration defines where the stream sends your data to automatically. You don't need to take care about this. And an export configuration can be created for AWS IoT Analytics, for Amazon Kinesis data streams, for AWS IoT SiteWise, or for Amazon Simple Storage Service. For example, if you want to send your data to your industrial data lake. You can also bring your own Lambda function, also your own writer Lambda function to write the data from your custom stream to an on-premise application or to another service which is not supported out of the box. So in the next slide, we will take a look at the architecture when you use AWS IoT SiteWise Edge. So you still use the collector lambda function from the AWS IoT SiteWise connector. And this lambda function writes then into a stream that is called SiteWise Edge stream. You can also bring, again, your custom lambda function to write into that stream. And then you have the component, our new capability, AWS IoT SiteWise Edge, that reads out of the SiteWise Edge stream and computes data at the edge, processes data at the edge, and writes results into the SiteWise stream. And at the SiteWise stream, you still have the publisher lambda function that reads the data from the stream and sends the data to AWS IoT SiteWise in the cloud. Of course, there's more functionality involved than reading from a stream, computing data, and writing them to a stream. You have also the local dashboard, the web application, the SiteWise monitor that runs also on AWS IoT SiteWise Edge. So if you want to interact with SiteWise streams, you need to follow a certain message structure like shown here. So you need to provide an alias. That's an alias, for example, machine sensor /3/temperature. Then you need to provide your value. That's a measurement. It can be a Boolean, double, a string, or an integer. Then you need to provide a timestamp in milliseconds. And you need also to provide the quality, which can be good, bad, or uncertain. You can batch multiple messages together for efficiency, because when you batch multiple messages together, you need less API calls. So, for example, you can send multiple messages with only one API call. So, and now I'm going to start a demo. In this demo, I will show you how you set up SiteWise Edge, how you send data to the edge and compute data at the edge. And you will also see how a local monitor, that means a dashboard at the edge, will look like. So let's get started with the demo. For the demo, I have already installed Greengrass on an AWS Cloud9 instance. And you can see here my Greengrass group. It's called SiteWise Edge group. I am here in the connector section, and you can see no connectors have been added to the Greengrass group. For SiteWise and SiteWise Edge, we need to have two connectors. We can add them automatically by configuring the gateway in the SiteWise console. So I will switch to the SiteWise console, to the gateway section. I have created already a gateway. And now let's have a look at the details. So first of all, we need to enable edge capabilities. But before we do that, let's take a look at the configured sources. You can see here two OPC UA servers configured for this gateway. And here you can see the default destination, as mentioned already in the architecture overview. By default, it's called SiteWise Stream. So now let's enable edge capabilities. So by enabling edge capabilities, multiple things happened. First of all, you can see here that the destination has changed to SiteWise Edge Stream. We also need to check if the destination options here are configured correctly. That means they must be set to SiteWise. We're going here to edit. And here you can see AWS IoT SiteWise. That's correct. Now let's switch back to our Greengrass group. I will reload the page to get the current connector configuration. And you can see here, two connectors have been added to my Greengrass group. So these connectors need also to be deployed to the AWS Cloud9 instance where Greengrass is running. So I use actions and deploy. And while the Greengrass group is being deployed, I will prepare my asset model for the edge. So we will go to the model section here in the Sidewise console. And you can see here a bunch of models already. Important are the models that contain edge in their name. So I have here a generator model. So this is a generator that produces energy, and it's normally hosted in plants. So let's go to the model. You can see here a new point that's configure for the edge. And you can see by default, no edge configuration is enabled. You have two options to enable compute the properties at the edge. That is either compute all properties or the custom edge configuration. That means you can decide which properties should be computed at the edge. I will use compute all properties at the edge and save. So in the next step, we need then to create a project and a dashboard in a Sidewise portal. I have created a Sidewise portal in the cloud already, and I'm logged in into this portal. And I need to create now a project and a dashboard, and this will be synced then to the edge. So that means, first of all, you need to create your resources here, like dashboards and projects in the cloud, so that they can be synced to the edge. So I will use here the Power Plant Edge 1 for my project. Add asset to the project, go to Next, and define a project name. Add asset to the project, and we are ready to create a dashboard. I will use some measurements from the generator 1, like the power output, RPM, and the temperature. Call it here generator ER1, and the dashboard will be named Edge Dashboard. I will save the dashboard. We're done in the cloud. We need to wait now some moments until the dashboard and the project has been synced to the edge. What you can see here is the Ops Hub for AWS IoT SiteWise application. This will be installed locally on a Windows machine or on your laptop, and you can use it for monitoring and troubleshooting gateways entirely locally, and you can also retrieve the URL for your local monitor from Ops Hub. Here you can see, for example, the address of your local gateway, the software version which is running. Then you can see some metrics about the system, like CPU utilization, free memory, and free storage. And here you have some metrics about the streams on your local gateway and also the error rate. So, but we want to retrieve the URL for our portal. You can find the URL here in this section, Sidewise Monitor Portals. If you don't have Ops Hub available, you still can construct the URL yourself, because it starts, of course, with HTTPS. Then you have your local IP address or your local DNS name, then portals, and then the portal ID of the portal from the cloud that has been synced to the edge. You can find the portal ID, for example, through the API, for example, with the AWS CLI with AWS IoT SiteWise list portals. So let's switch then to the local portal. So I logged in already before into that portal, so therefore I will not be again prompted for credentials. And what you can see here now, it's the Edge dashboard. That is a dashboard that we have created in the cloud, and that has been synced now to the Edge. So let's take a look at this dashboard. And you can see here already some data in the dashboard. So that means everything is working. Your data are consumed and computed at the edge, and your dashboards are also at the edge. So this is a total local monitoring application. In the last part of the demo, I want to show you how you can query the API at the edge. So that is the same API like in the cloud, but you need to use another endpoint, your local endpoint. First of all, let's list the asset models. What you can see here is I use the normal AWS CLI. The service is called IoT SiteWise Edge. I need to provide another endpoint, in this case localhost and port 8443. I need to define no verify SSL because we use a self-signed certificate here at the edge. And now let's go. You can see here all the asset models that have been created. And in the next step, I will show you how you can get an asset property from your assets. We will also use, of course, the local endpoint, and we will get the power output for our generator 1 here. So you can see here the value for the power that is currently generated. So that is an option how you can consume your data also at the edge, and this will also work even if you don't have a connection to the cloud. So, and with this, I'm at the end of my demo. Okay, now in the demo, you have seen how you can set up AWS IoT SiteWise for the edge, how you can compute data locally, also how you can access data locally with the same APIs that you use in the cloud. And I hope you have learned in this session different data processing options, how to set up AWS IoT SiteWise at the edge, not only by the demo, but also by the architecture that I presented. And you have also learned how to visualize your data at the edge. Yeah, if you want to get started, please examine our AWS IoT SiteWise resources at aws.amazon.com/IoT-SiteWise, or simply go to the Management Console and start building your Edge setup or your Edge projects. And in case you have any questions, please contact your AWS account team or contact us under aws.amazon.com/contact-us. Yeah, we are now at the end of this session. I like to say thank you for your attention, and we love also to hear your feedback. So please complete the session survey. Thank you again.